We are going to go over the two mean inferences in SAS for independent and then dependent samples. So let's first do the independent samples, where the first population one is first and then the second population. This is of the form proc t-test data is equal to whatever the data set is. Order is equal to data to keep the order of the data correct. Alpha is equal to whatever the significance level is as a decimal. Test is equal to diff. SAD is equal to L, U, or 2 for less than, greater than, or not equal to. And then H0 is equal to whatever the null hypothesis is, which is typically 0. You could technically leave that one out because it will automatically just default to 0, unless of course you want it to be a different number. The class, and it's best for me to show an example here like the one that I'm about to do. The class, when I say class is equal to the leftmost variable, that means when you have the data set formatted like this, where you have one column where you have the two variables listed, 3 times each. The stat column here in the middle has the sample size, sample mean, and sample standard deviation for all three, coded as such, and then the actual values in the rightmost column. Like in this one here, it has the average number of shoes that women and men own, and the leftmost variable for this, the class, will be the very first variable here, which would be gender, and the second one here, variable, this would be the rightmost variable, which holds all the counts, that being the shoes column on here. And then we would run it. So to use this in SAS, let me very quickly import this data into SAS so we can actually use it. Alrighty, so for this, and that was not what I wanted to do. I'm on this one. Okay, so for this we are using, for the data set we're doing work dot shoes. We are using the alpha of 0.05, and the SAD we are going to use, let us use a not equal to, so 2. And then the null hypothesis is going to be 0. The class variable for this is going to be the gender variable that I have on there, and the variable is going to be, which has the counts, is going to be shoes, and then we're going to run it. And then it runs the two mean test for it. It gives us, when we have unequal variances, it gives us the p-value. If we had equal variances for whatever reason, it gives us that as well. Do note that these are not always necessarily the same. And it also gives the confidence interval as well for the two differences. If it was either the center width or the pooled options. And then the quality of variances are down over here on the bottom as well. The confidence interval for the 95% confidence interval for the mean is indeed noted on here as well. So we have both the hypothesis test and the confidence interval, both of which are labeled underneath Satterthwaite for this particular test. Now for the pooled test, the one that's paired, we need to do a slight difference here in our calculation. Alright, and I'm going to use this temperature data set, that being this one, where we have the data into two columns. And here for temperature at 8 a.m. and for 12 a.m. Let me just very quickly put that into SAS here before editing this. Notice on the left here for the dependent samples, the only difference between these two is that we now just have paired the first population asterisk the second population. This is presuming the first population is first, of course. Whichever one's first goes first. So for this, we're going to be using the temperature data set. And I'm going to keep the other options here the same. Alpha of 0.05, not equal to alternative hypothesis, and the null equal to 0. And for this, I'm going to use paired, the first population or variable in this, which is going to be temperature at 8 a.m. asterisk temperature at 12 a.m. followed by a semicolon. And then when I hit run, it's going to give us the matched pairs to mean inference on here. Once it goes about doing so, of course. I have to give it a few moments. Okay. This time now, it's going to give us the various summary statistics. It gives us the confidence interval for the mean and for the standard deviation. And it also gives us the hypothesis test here, the t-value and then the p-value. And then it also gives us various histograms. This one here of the confidence interval. We have a paired profile. We have a scatter plot. And then we finally have the QQ plot for the difference for us to determine normality. Let me know if you have any questions or concerns. Thank you.